Hello everyone. Today, I want to introduce mixer circuit to you. Modern communication devices, including most cell phones, utilize mixer circuits. These circuits perform frequency mixing, which essentially involves multiplying two input signals. Ideally, a mixer operates by multiplying an input signal, cosine A, with a local oscillator signal, cosine B, to produce an output signal of cosine A cosine B. This output can be simplified to 1/2 cosine A add B plus cosine A minus B. Mixers can be implemented using diodes or transistors. Figure A shows an example of a diode mixer, and Figure B shows an example of a FET mixer, based on their physical principles. There are two main methods to realize the function of a mixer: the nonlinear method and the switch method, which I will explain in detail later. The nonlinear method utilizes the nonlinear characteristics of diodes or transistors to produce the effect of multiplying two signals. A single-ended diode mixer, as shown in Figure A, is an example of this method. The duplexing coupler first combines the RF and LO input signals, which are then fed to the mixer. A DC bias current is provided to the diode using an RF choke. The DC bias ensures continuous current flow through the diode, enabling application of diode small signal analysis on both RF and LO inputs. Figure B shows an idealized equivalent circuit of this mixer. This simplified model helps us understand how the RF and LO inputs interact with the diode to generate the desired output signal. Let's look into math analysis. Input signal can be represented as VRF cosine omega, RFT. Output signal can be represented as VLO cosine omega, LOT, with diode small signal model. The diode current can be represented as I0 plus GD VRF plus VLO plus G prime half VRF plus VLO squared. Use filter circuit, and we can leave third term only. The current becomes the below formula. We can use more low-pass filter to filter all signal except the signal of cosine omega RF minus omega LOT. This frequency is the intermediate frequency which we want. The final IF output signal becomes G prime half VRF VLO cosine omega IFT. This method is called nonlinear method. Another implementation method, known as the switch method, utilizes the LO signal to control the switching of the output signal between positive and negative input values based on the LO's frequency from the Figure A. We can use low signal to switch output signal from positive input signal to negative input signal. Periodically, Figure B is the corresponding waveform. We can see the if waveform is the product of our F and LO waveform. This is possible because the Fourier series representation of a square wave like the LO signal includes a component at its fundamental frequency, omega LO, by incorporating a bandpass filter, designed specifically for the desired frequency. Other unwanted frequency components generated during the switching process can be effectively removed. Figure A depicts a single balanced FET mixer employing the switch method. The two upper FETs act as switches, manipulating the RF signal based on the low signal's frequency. This switching action ultimately generates the desired if signal at the output. Notably, the lower FET functions as an amplifier, boosting the output signal's gain. Making this an active mixer, by replacing the lower FET with a resistor, we can create a passive single balanced FET mixer. By definition, active mixers offer conversion gain on the output signal, while passive mixers do not. Both the nonlinear and switch methods generate spurious signals, known as unwanted frequencies. These include fundamental frequencies, second-order products, third-order products, and higher-order products. To mitigate these unwanted signals, advanced mixer architectures like single-balanced and double-balanced designs utilize strategically placed diodes and transistors. These architectures effectively suppress or reduce unwanted frequencies, improving the mixer's signal purity. Here are the mixers with different architecture, including single-end diode mixer, single balanced diode mixer, double balanced diode mixer, which also called ring mixer, single end FET mixer, single balanced FET mixer, and double balanced FET mixer, which also called Gilbert cell. If you are interested about the details of these mixers, you can find more advanced material by yourself or wait for our future explanation. Here is the comparison table. Unbalanced mixer is simple and implements mixing based on the nonlinear properties of devices, ideal for high millimeter wave and terahertz frequencies. The disadvantage is requiring bulky filters to separate desired signals from unwanted frequencies. Single balanced mixer can suppress other unwanted order products frequency. Also, increased linearity compared to unbalanced mixer. The disadvantage is requiring a higher driving level for the local oscillator signal. Double balanced mixer also can suppress other unwanted order products frequency. Also increased linearity compared to single balanced mixer. The disadvantage is to rely on precise symmetry and matching of diodes or transistors, which can be challenging to achieve. Finally, you may wonder that there are so many different mixers. How do I choose the right one? Here is my understanding. Diode is better than CMOS to build high-frequency mixer because the capacitor in diode is smaller than in CMOS. Nonlinear method is better than switch method to build high-frequency mixer because using diode or CMOS as switch is not ideal at high-frequency range. Most of unbalanced mixer is implemented by nonlinear method, so unbalanced mixers are described good for wave and terahertz on the previous slide. If you want to build mixer for high frequency, choose diode mixer first. If the balanced diode mixer cannot meet your requirement, then try unbalanced diode mixer. Conclusion: mixer can be implemented by nonlinear method or switch method. Mixer can be implemented by diode or transistor. There are passive or active mixer. There are unbalanced, single balanced, and double balanced mixer. To help you understand and remember these different types, I organized the tables right. If you're interested in learning more about mixer architectures, here are some topics to explore. 1. The Gilbert mixer. This is the most popular mixer architecture, used in integrated circuits. 2. Balanced diode mixers. Both single balanced and double balanced diode mixers are widely used architectures. 3. Generating square waveforms. Oscillators are key components in generating square waveforms for mixer applications. 4. Exploring further, dive deeper into other mixer architectures like harmonic mixers, image reject mixers, and more. Thanks for watching. Don't forget to subscribe and like for more tech stuff in the future.